Let us take example of sodium. The symbol of sodium is Na. We know that there are 11 electrons of sodium. Also, we know that in the first orbit, maximum 2 electrons can be filled. So, first 2 electrons will be filled in the first shell. How many are left? Total 11 are there. So, 9 are left. In the second orbit, we know that we can fill 8 electrons. So, out of 9, 8 electrons will be filled in the second orbit. How many left? 1. So, where will be 1 electron be filled? It will be in the third orbit. So, here for sodium, we will have 1 electron in outermost orbit. Here, total 11 electrons are there, so we have 3 orbits. There can be other examples where we will have 4 orbits or 2 orbits. Okay, here we have 11, so we have 3 orbits. So there will be 1 electron in outermost orbit of sodium. Now what will happen? I have already told that all the elements will try to attain octet configuration like noble gases, which means they will try to get 8 electrons in their outermost orbit. Now you see for sodium. Here, sodium has 1 electron in outermost orbit. So what will it do? Will it give electron or will it take electron? We have all this studied in standard 9, right? Which is the easiest, to give 1 electron or to take 7 electron? It is easy to give away 1 electron, right? So what the sodium will do? Sodium will give 1 electron, and if 1 electron will be given, then there will be 8 electrons in outermost orbit. So sodium will lose 1 electron and it will attain octet configuration. And when sodium loses 1 electron, it becomes sodium ion. Now here you need to remember, whenever any element loses an electron, it becomes positive ion. Positive ions means cation. Remember these words, cation. Whenever any element loses electron, by giving away electron, it becomes positive ion, and positive ion is called cation. So earlier, sodium has 281 configuration. Now by giving away 1, it will have 28 electrons, right? Remember, by giving away electrons, the elements become positive ion, which is cation. Let us take an example of a non-metal, which is a chlorine. Chlorine has atomic number 17. How will we write electronic configuration for it? It will be 287. Why is it so? We know that in the first orbit we can fill maximum 2 electrons. In second orbit we can fill 8 electrons. Okay, so out of 17 we will fill 2 electrons in the first orbit. How many will be left? There will be 15 electrons left. Now in second orbit, we can fill maximum 8 electrons. So out of 15, we will fill 8 electrons. Now how many are left? 7 electrons are left. So that 7 electrons will be filled in the third orbit. Now, here you see there are 7 electrons in outermost orbit. As we have discussed earlier, all the elements will try to attain octet configuration as noble gas, which means they will try to attain 8 electrons in their outermost orbit. Here, for chlorine, there are 7 electrons in outermost orbit, which will be easy to give away 7 electrons or to take 1 electron. I am sure you are thinking that it will be easy to gain 1 electron or to take 1 electron. So, chlorine will gain 1 electron, and by gaining it will have total 8 electrons in outermost orbit. Earlier it was 7. When it gains 1 electron, it becomes 8 electrons. Now, by gaining electron, it becomes chlorine ion, and it is negative ion. Negative ion is called anion. Now recall for sodium. Sodium loses electron and it becomes positive ion, that is cation. Here chlorine gains 1 electron and becomes negative ion, which is called anion. Please remember the difference. It is very much easy. Elements, by losing an electron, becomes positive ion, which is called cation, and the elements gaining electron, they become negative ion, which is called anion. Now let us learn formation of NaCl, that is sodium chloride. Now we have already learned that sodium loses electron and it becomes cation, positive ion, whereas chlorine gains 1 electron and it becomes chlorine anion. So there is a give and take relation between sodium and chlorine. Okay, remember this word. There is give and take process between sodium and chlorine. Sodium is giving, chlorine is accepting. So there is give and take relation. Also, we know that sodium is positive ion and chlorine is negative ion. If we talk about sodium and chlorine ions, sodium is positive ion and chlorine is negative ion. Remember students, when it becomes ion, when it takes electron or gives electron. Before that, it is an atom. Okay. Now, as sodium and chlorine are oppositely charged, sodium is positively charged, chlorine is negatively charged ions. So, as they are opposite charges, they attract each other. We know that opposite attracts. So, here also, as being oppositely charged, sodium and chlorine ions attract each other. And because of this attraction force, they are held by strong electrostatic forces of attraction, and they become sodium chloride, which is NaCl. So remember that the compounds, when they are formed by opposite charges attraction, they will form the compounds, and these compounds are known as ionic compounds. So the proper definition of it will be the compounds form in this manner by transfer of electrons from a metal to a non-metal are known as ionic compounds or electrovalent compounds. Please remember this definition of ionic compounds. They are also said as electrovalent compounds. What are they? The compounds formed by the transfer of electrons from a metal to a non-metal are known as ionic compounds or electrovalent compounds. It is very much easy. Here we can see sodium is metal and chlorine is a non-metal. So transfer of electron has taken place from sodium to chlorine, which means from a metal to a non-metal. So this is called ionic compounds.